So we have a question here that talks about a pendulum swinging and it's directly proportional. So it's telling us that this is a proportional relationship. So what we need to remember about proportional relationships are that they start at 0 and there's always a k value involved. So if we were to plot the t is directly proportional to the square root of L. So if we were to plot the square root of L against t, no, it would be t against the square root of L, then we'd end up with a straight line where the gradient would equal k, the proportionality constant, and that's what direct proportion is about. So basically, because we're asking to work with this relationship, then we know that t is proportional to the square root of L, so t would equal the proportionality constant times L. Now, they're talking here about the length of the pendulum being increased. They're not actually telling us the lengths, they're not actually telling us the times, so they're asking us to work in a kind of an abstract way. So we need to use subscript language here because we have to think of the initial conditions, so we'll call those T1 and L1. So the initial time period and the initial length, and there's a constant that goes between those two. Now the thing about proportionality is the constant cannot change. So in this case, to find k, we would have done the time divided by the length. Now in the second conditions, it's telling us that the pendulum is increased by 40%. So the length of the pendulum L2 is equivalent to 1.4 times L1, an increase of 40%. So we now know that the second conditions tell us that T2 would equal k times L2. K is a constant, so k would be equal to T2 over L2. But because k is a constant, then we know that the relationship says that T1 over L1 is equal to T2 over L2. But it wants to work out the increase in the time period. So in other words, we need to know how T2 relates to T1. So we need to rearrange this to be T2 over T1. We divide through by T1 and the L2 would come across by timesing. So T2 over T1 would equal L2 over L1. Now the thing I've forgotten is that this is about square root relationships, so I've got to be careful that I do put the square root sign in. So let's go back through and check that we've done that properly. So T1 equals k times the square root of L1. T2 equals square root of L2, so this will be the square root of L1, the square root of L2. And this would be the square root of L1, the square root of L2, and this would be the square root of that, and the square root of that. Okay, so it's important that we remember that this is about square root relationships. So again, the idea of checking through what you're doing. We do know that L2 can be replaced by 1.4 times L1 now. So we recognise then that the relationship between T2 and T1 is equal to the square root of 1.4 L1, because that's the pattern between L2 and L1, divided by the square root of L1. Now the way square roots work, they're part of the surds family, so surds require us to put those into the same square root, because the rule says we can. So we end up with 1.4 L1 over L1. Well, L1 divided by L1 cancelled, so this becomes the square root of 1.4. So we basically square root 1.4 equals. So T2 over T1 is equal to 1.1832. Now the way we interpret this is we're going to say that it's a 18.3% increase. So it says work out, because 1.1833 is a percentage multiplier, so we times that by 100 to get a percentage, so it's 118.3%. So the ratio of those two is 118.3%, so T2 is equal to 118.3% of T1. So the answer is 18.3%.